Warm welcome everyone. Now that you've read the paper, we'll skip to the practical part in a moment. If you haven't read the paper yet, please take a moment to read chapters 1 to 4. In these chapters, you will find definitions and explanations of the following key concepts: Translationese, machine translationese, empty priming, post-editing, and Post-Editese. Now, some information about our research subject. We have one source text in British English. This text is an extract from the terms and conditions of the publisher Pan Macmillan Publishing. That means we are dealing with legal language. If you are uncertain about the characteristics, you can find some examples in Chapter 5 of the paper. Then, we have our first type of target text. One raw NMT output by DeepL. Don't worry too much about the N in NMT. It means neural and refers to the way the system works and translates, as briefly described in the introduction of the paper. For now, all you need to know is that this text has been machine translated and not edited in any way. For our second type of target text, we selected 5 fully post-edited NMT outputs. And for the last type, we selected 5 human translations from scratch. All target texts are in German. If you like, you can download the texts from our repository and follow the analysis step by step. You can find the link in Chapter 4 of the paper. The key questions that accompany us are the following. How does the degree of NMT integration in the translation process affect the target texts? How do the different target text types differ? Previous research has proven the existence of translationese. Can we identify traces of machine translationese and post-editese? If so, what characterizes these two? Already during the video, you will get insights into these questions, and at the end, we'll summarize the answers together. In current research, we can often find claims that both lexical variety and lexical density increase from machine translation to post-editing to human translation. But what does that exactly mean? Let's find out. Lexical variety describes how diverse the vocabulary in a text is. This can be assessed by calculating the type-token ratio, which we do by dividing the number of types by the number of tokens. Tokens are all individual words in a text. Types are the different word forms in a text. As you can see in this example, we have 2 sentences. My black dog chases the red ball. The black dog chases the black ball. Now we can count 7 individual words or tokens in each sentence. The first sentence also has 7 different words or types, but the second one has only 5 types because the words the and black are counted once. To calculate the type-token ratios, we need the individual numbers of types and tokens for each text. As a reminder, we have 1 neural machine translation output, 5 post-edited NMT outputs, and 5 human translations. We are calculating the lexical variety with basic tools, such as AntConc and Excel. Please note, however, that the decision of which tools you use will affect your analysis results. Depending on the tool, results may vary slightly due to differences in tokenization. This means that different tools may display different numbers of types and tokens for the same text. AntConc is a freeware corpus analysis toolkit for text analysis. We recommend that you watch the following introductory videos, which are linked in the paper. Tutorial 1, Getting Started. Tutorial 5, File Tool Basics. Tutorial 8, Word List Tool Basics. For Excel, we've created a template that makes it easier to calculate the type token ratios and visualize the results. You can download the template via the link in Chapter 4 of the paper. For the analysis and some examples, we're now moving onto the tool part.
So after the first part of our presentation, we're now moving on to the actual data analysis. In this part, we're assessing the lexical variety of our different target texts, which are the NMT output by DeepL, the 5 different post-edited outputs, or MTPE for short, and the 5 different human translations from scratch, or HT for short. The first tool we're using is AntConc. Please note that we're using version 4.1.0. It's okay if you use an older one, but the UI of older versions may look slightly different. Today we're working with the word list tool. This tool is very handy because it features indicators for the numbers of types and tokens of imported texts or corpora. We now want to import our files individually to get the number of types and tokens for each text. We do that by clicking on File and then on Open Files as Quick Corpus. In older versions of AntConc, this option may read differently, such as Create Quick Corpus. And then we just navigate to the folder containing our files and select the first one. I'll go with the NMT output here. Then click on Open and OK, and in the word list tool, click on Start. Now we can see that AntConc has created a word list containing all the different types in our file. We can also see some metadata, for example, how frequently each type occurs. So, as outlined earlier, we need the number of types and tokens. Here we have 131 types and 287 tokens. Now, you could write that down and then calculate the type token ratio for each file manually, but that would be very inefficient, wouldn't it? The more data-savvy option would be using a tool to calculate the type token ratios and to compare and visualize the results. To do this, we've created the Excel template Lexical Variety Density, which already contains columns for the different texts, for the numbers of types and tokens, and a column for calculating the type token ratio, or TTR for short. So, now we can type in the values of our first file, the NMT output. 141 types and 287 tokens. As we've learned earlier in our presentation, the type token ratio is calculated by dividing the number of types by the number of tokens. So we just divide this cell by this cell, and as you can see, the type token ratio of the NMT output is 0.491 and so on. Actually, we don't need this many decimal places, so we can just reduce them to about 3 in order to get a better overview. Now, to create meaningful data, we need to get the type token ratios of all our texts and compare them. We can do this by repeating the steps we just went through. So, in AntConc, we just click on File, Open Files as Quick Corpus, and select another file, for example, the first post-edited output, A1. Click on Open, and OK, in the word list tool, click on Start. Here we can see that AntConc has created a new word list for our second file. This text has 157 types and 301 tokens. Now we just have to calculate the GTR again. So we just go to the template and insert our values just as we did before, and then we again divide types by tokens. And we can see here that this post-edited text of A1 has a higher type token ratio and is therefore more lexically diverse than the raw NMT output. Now we just have to get the values for all files. And if you're done, your template should look like this. We know that numbers and values might seem well abstract to you, so we recommend that you visualize your data in charts to make them more tangible. Luckily, Excel provides suitable tools for converting tables into charts. For example, we want to visualize the numbers of types and tokens for each text. To do so, we mark the required data, this one, then click on Insert and Add Charts, select the type of chart we want to visualize our data in. I'll go with a line with markers here. To give us a better overview, we can also add metadata. For example, data labels to include the number of types and tokens as digits. We do this by clicking on the chart, then on plus, and checking the box here at Data Labels. So what does this chart actually show? On the horizontal axis, we can see our different target texts. The blue line represents the number of types and the orange one the number of tokens. We can see that B10, human translation, has the highest number of both types and tokens. Additionally, B7 has the lowest number of tokens and one of the lowest numbers of types. Interestingly, B8 and B9 display identical values. Now, that's all very nice, but this chart doesn't say a lot about lexical variety yet. Instead, we need to visualize the different type token ratios. So we mark our text and our ratios, click on Insert and create another line with markers chart. Can just even out bounds and include the data labels as we did before to include our type token ratio values as digits. And in this chart we can see that two of our post-edited texts, A1 and A2, have a higher type token ratio and therefore a higher lexical variety than our NMT output. A3, A4 and A5 display relatively similar values compared to the NMT output. We can also see that, except for B10 here at the end, all human translations, B6 to B9, have a higher type token ratio than the NMT output and the post-edited texts. As I said, the exception is B10, but this text only has a lower type token ratio than A2. Now, in our presentation, we talked about a trend, describing that lexical variety is supposed to be lowest in NMT, higher in post-editing, and highest in human translation. To support this, we can add a trend line to our chart, which we can do by clicking on the chart, on the plus, and checking the box here at trend line. In our example, this trend line shows that the type token ratio, or lexical variety, tends to increase from the NMT output to the post-edited texts, and from there to the human translations. But of course, there are the notable exceptions of A3 to A5 and B10, which fall under the trend line. So, now that we've analyzed our data, it is time for interpretation. Lexical variety is relatively low in the NMT output because NMT systems prefer the translation solutions most frequently used in the training data. A post editor may or may not add lexical variety to some degree, which they can do by adding, explaining, rephrasing, deleting, and other measures. But because MT primed them, the resulting translation is unlikely to achieve the level of lexical variety that is attained in human translation. In other studies, however, a clearer picture emerged. For example, Terrell 2019 found that lexical variety is lowest in NMT, higher in post-editing, and highest in human translation.
Now that you've learned more about lexical variety, we'll move on to lexical density. Lexical density describes the amount of information in a text. This can be assessed by calculating the ratio between the number of content words and the number of all individual words in a text. We already know the number of tokens for each text, But what exactly are content words? Content words possess semantic content and contribute to the meaning of the sentence in which they occur. Many count nouns, verbs, adjectives, and adverbs as content words. But does that mean all verbs? What about auxiliary verbs? They don't add much meaning to a sentence, do they? Or proper nouns, which we think do. Depending on what you count as content words, different values for lexical density will result. So, in our analysis, we are counting nouns, proper nouns, verbs, but no auxiliary verbs, adverbs, and adjectives. Examples for this will follow in the upcoming tool part. We are calculating the lexical density with basic tools such as TagAnt, AntConc, and Excel. TagAnt is a freeware multi-language segmenter and part of Speech Tagger. It marks every word with its POS, for example, website noun. Please note that automatic POS taggers sometimes assign incorrect POS tags. We are looking at a few examples in the tool part. Also, other POS taggers may produce slightly different results. After tagging, we count the part of speech tags for the content words using the word list tool in AntConc. For Excel, we've prepared a template to help you with calculating the lexical density and visualizing the results. The template is the same we used earlier when we discussed lexical variety. For the analysis and some examples, we're now moving on to another tool part.
Now, putting theory into practice, we're now assessing the lexical density of our different texts. In this folder right here, we have our different target text as Word files, and here we have the Excel file, which also contains a template for calculating the lexical density. In this template, you can insert the numbers of content words and the numbers of tokens. As outlined earlier, we're counting nouns, proper nouns, verbs, adjectives, and adverbs. We then add the number to get the total number of content words in a text. This number is then divided by the number of tokens to get the lexical density for each text. Luckily, we already know the different numbers of tokens from assessing the lexical variety earlier. Now, of course, you don't want to count the content words by hand, so we offer you a smart solution by using TagAnt, AntConc, and Excel. First, we need the numbers of the different content words. We get these by POS tagging our text and counting the POS tags. The tags we're using are quite simple, because we're using universal POS tags. What does it mean? Well, you see, for POS tagging and other stuff, TagAnt uses Spacy, which is a Python library. For the purpose of this video, you can imagine it as a folder containing a range of models and functions to process natural language. And this library also contains POS tags. The universal ones only include general POS tags, for example, like adjectives, adverbs, auxiliary verbs, determiners, nouns, proper nouns, pronouns, and verbs. Please note that there are more complex POS tags than this. For example, Spacy also includes a German POS tag set, which includes various more complex tags. For example, instead of just one verb tag, this one includes about 12 different tags for verbs in various moods, tenses, and voices. But for our analysis, the universal POS tags will do just fine. So, now we're importing our files into TagAnt. We do this by clicking on File, Open Directory, and navigating to the folder containing our files. We then need to select the language, German of course, and the display information. Here we need to select Word plus POS. This will make sure that TagAnt only uses the universal POS tags, not the more complex ones. If you want to use those, you need to select word plus tag. We can leave the other settings as they are. Now we click on Start, and TagAnt starts tagging our files. Once the process is completed, we can find the tag files in our original folder in the folder tagged. So in the folder, we can see that TagAnt has created new plain text files containing our tag target text. We can look at one example. In the NMT output, the header, which originally read Terms and Conditions and now reads Bedingungen und Konditionen, has been correctly tagged as 2 nouns and 1 coordinating conjunction. So you see that using TagAnt for tagging our files is very efficient, but sadly isn't exactly flawless. For example, some enumerations have been tagged incorrectly. First as adjective, third as adjective, and fifth as an adverb. If these mistakes aren't considered, they'd inevitably influence the results of our data analysis, but more about that later. So, now that our tags are tagged, we can use AntConc to count the POS tags. So we open the tool and import the files just as we did when we were assessing the lexical variety. Please note that we have to import the files individually again. So we click on File, open Files as quick corpus, navigate to the folder containing the files, and use the tagged files this time. Click on OK, and in the word list tool, click on Start. And in this newly created list, we can see that AntConc has not only counted the original words as types, but also our POS tags, such as noun, punctuation, or determiner. We can use this to our advantage because the frequency of a POS tag tells us how many of that POS are in the text. So if we want to know how many nouns there are in the NMT output, we just can type in noun and confirm with enter or start, and the tool gives us the information that there are 76 nouns in the text. And we do this again for the other content words. For example, we can search for the POS tag prop-n for proper nouns, and then we can see that there are 2 proper nouns in the NMT output. We're also looking for verbs. There are 29. For adjectives, which you can find with the POS tag adj, there are 9 adjectives, and for adverbs, adv, there are 15. So, we then open our template and insert the values in the respective cell. So 76 nouns, 2 proper nouns, 29 verbs, 9 adjectives, and 15 adverbs. And here we can see that the total number of content words in the NMT output is 131. There are 287 tokens, and if we divide the total number of content verbs by the number of tokens, we can see that the lexical density of the NMT output is 0.456. Now we just have to repeat this for each of the other texts. And if you're done, your table should look like this. If we want to, we can now visualize our results just as we did earlier. This chart, for example, shows the lexical density values of our text. We can see that the NMT output here on the left has the lowest lexical density value. We can also see that all of our post-edited texts, A1 to A5, have higher values, although A3 to A5 show relatively similar values compared to the NMT output. The human translation B7 and the human translation B9 show the highest lexical density values. The other human translations also score relatively high, but are just beaten by the post-edited text of A2. All the other texts score lower than the human translations. Now, coming back to our claim from the beginning of our presentation that NMT outputs and post-edited text have a lower lexical density than human translations. If we take a look at the trend line in red, this seems to be true. However, the values are relatively close to each other, and there are notable exceptions falling under the trend line, so there is room for doubt. The question remains whether the level of lexical density is a systematic difference between the translation scenarios or not. But now you might wonder, what about the incorrect POS tags from earlier? Good question. If you look through the files manually and correct the POS tags, and then count the tags with AntConc again, these are the results. Since most of the incorrect POS tags were content word tags, the lexical density of all text is slightly lower. The duration ranges from 0.014 to 0.027. In this chart, the red line shows the corrected lexical density values. Now, if we want to compare the corrected and the original values visually, you can just click on the original graph in blue, press Ctrl and C for copying, and then click on this chart and press Ctrl and V for pasting. Then it becomes obvious that the corrected values are lower, but that the incorrect POS tags didn't influence the course of the graph or the overall results of our analysis, if you want. So, we've almost reached the end of the presentation. But before you go, we wanted to show you how you can use AntConc to look at more detailed differences regarding lexical density and variety. For example, you can create a corpus in AntConc to quickly switch between the files and see how DeepL, the post-editors, and the translators handled interesting lines in the source text. So, in AntConc, we again click on Files and Open Files, click Corpus, and then import our text files. And this time we want to import the files that have not been tagged and the English source text as well. Open and OK. Then we open the File tool and click on Start to load the files. So we just want to show you one example here, but you can find other examples of our analysis results in our paper. The sentence we want you to look at now is this one. Bear in mind that we may identify you if we are requested or ordered to do so by a court or by any other competent authority. More specifically, we want you to take a look at these two verbs, requested or ordered to. Their meanings are relatively similar, so it's interesting to see how DeepL as an NMT system has translated this. So we just look at the translated sentence in the NMT output, which is this one. Denken Sie daran, dass wir Sie identifizieren können, wenn wir von einem Gericht oder von einer anderen zuständigen Behörde dazu aufgefordert werden, dies zu tun. We can see that the structure is almost identical to the source sentence. Requested or ordered to has been translated as aufgefordert oder aufgefordert. So DeepL used the same target language verb for two different source language verbs. This is probably due to the fact that in the training data of DeepL, both request to and order to have most frequently been translated as auffordern. We can now compare this finding to one of the post-edited texts, A5 for example. Here the text reads, denken Sie daran, dass wir Sie identifizieren können, wenn wir vor einem Gericht oder einer anderen zuständigen Behörde dazu aufgefordert oder angeordnet werden. Now this is interesting, because the post editor has made relatively few changes, leading to similar lexical variety and density. One of the differences is that they selected another verb to match the source text. Instead of the second aufgefordert, they chose angeordnet, which is fine since auffordern and anordnen have similar meanings to request and order to. This change, however, results in a slightly higher lexical variety. It has no impact on the lexical density of the sentence though. Finally, we can compare these findings to one of the human translations, B7 for example, which by the way has the highest lexical variety and lexical density of all target texts. Here, the sentence reads: Beachten Sie, dass Ihre Identität auf gerichtliche oder behördliche Anweisung zurückverfolgt werden kann. Now this sentence is particularly interesting. For example, we can see that it is much shorter than the ones we saw in the NMT output and the post-edited text. We can also see that the original if clause has been condensed into the object auf gerichtliche oder behördliche Anweisung. So our two verbs request in order to have been condensed into the single noun Anweisung. In conclusion, we can generally say that these strategies result in a higher lexical density and variety, because this target language sentence has both a higher type-token ratio and a higher ratio between content, words and tokens than the sentences we saw in the NMT output and the post-edited text. So, we've reached the end of our presentation. Thank you very much for watching. If you'd like to continue reading, you can find more analysis examples in Chapter 5 of the paper. Chapter 6 contains a conclusion to this learning journey, and you can find our references and sources in Chapter 7. Goodbye.